in this video, we're going to discuss this big idea of composition of transformations. Now, whether you know it or not, you've actually already done some composition with transformations. Composition of transformations is just taking two or more transformations and performing them both in the same problem. And they're going to be given to you in the form that's given there at the top of page 18. It says the composition of transformations are given in this form. And then they give you a couple different transformations that are separated by that symbol or that open circle. And that open circle may or may not be a new symbol for you. If you haven't seen that open circle before, what you need to know is that open circle really means the word following. So the way that you would read this is to say a reflection in the x-axis following a reflection in the line y equals x. And because we're following the reflection in the line y equals x, this is actually going to be our starting point. We're going to begin by reflecting our figure over the line y equals x, and then we're going to end, or we're going to finish by then reflecting that image across the x-axis. So again, you might think about this as working right to left, but I like to think about this little symbol meaning the word following. All right, let's jump into this and have some fun. Number 1 says, find the image of the triangle with the given coordinates after a reflection in the x-axis following a translation which moves the object 3 units in the x direction and 4 units in the y direction. So again, probably the biggest takeaway from today's video is that you have to know that little symbol means the word following. So like most transformations that we've done, the very first thing I'm going to do is go ahead and plot those points and get that triangle down on my coordinate plane. So there's point A, point B has coordinates 1, 6, and point C has coordinates 6, 6. Let me grab my straight edge. Now I've successfully graphed the pre-image. Now I'm going to go ahead and perform some transformations. As far as that translation at the end, there are a couple different ways that you can deal with this. You can say that I'm going to start with the original coordinates, and to each of the x values I'm going to add 3, and to each of the y values I'm going to add 4. I'm going to think about that translation as the shift or the slide that moves each point in the image 3 units to the right and 4 units up. So I'm going to go ahead and start at point C, and I'm going to move 3 units to the right, 4 units up, and I'll end up at point C prime. I'm going to move point B 3 units to the right and 4 units up, which will take me to point B prime. And lastly, doing the same thing for point A takes me to point A prime. And since these guys aren't my ultimate endgame, it's not my finished product, instead of connecting them with a solid line, I'm going to connect them with a dotted line just to kind of indicate to me, or as a reminder to myself, that this is kind of an in-between step. I've started the problem, yet I haven't completely finished it. It doesn't say to state the coordinates, but for the purposes of making this a little bit easier to follow for you as you view it, I'm going to go ahead and state the coordinates. So A prime has coordinates 4, 6, B prime has coordinates 4, 10, and lastly the coordinates of point C prime end up being 9, 10. So again, that was the first step in the process, and that's where I'm at after performing the translation that shifts each point 3 units to the right, 4 units up. Now that I've done that, the last thing I need to do is I need to perform this reflection over the x-axis. So I'm going to take my purple triangle, the one that I got after performing the translation, and that purple triangle is the one that's going to be reflected over or across the x-axis. So point A prime is going to move down here to 4, negative 6 and become A double prime. Point B prime is going to move down here to 4, negative 10 and become B double prime. And point C prime is going to be mapped down to 9, negative 10. And since this is my finished product, I am going to grab my straight edge. I am going to draw with solid lines to indicate that triangle ABC double prime is my finished product. And again, although it doesn't state or ask me to state the coordinates, Just so that we can be perfectly clear, I'm going to go ahead and state each of those coordinates. A double prime was 4, -6. B double prime had coordinates 4, -10. And C double prime ended up at the point whose coordinates are 9, -10. All right, so that would be our final answer. In the picture, the blue triangle, the triangle that exists after I've performed the translation and the reflection across the x-axis. All right, so that's the whole idea behind composition, performing 2 or more transformations on the same object within the same problem. All right, let's go ahead and take a look at the next one. This one, too, is asking us to deal or perform some transformations on a triangle. This one says, though, a reflection in the x-axis following a reflection in the y-axis. So once again, the very first thing that I'm going to do is I'm going to go ahead and put that pre-image on my paper. So point A with coordinates -2, 2 is right there. Point B with coordinates -2, -4 lives down here in quadrant 3. And point C with coordinates -8, 5. He belongs up here in quadrant 2. So now that I have my pre-image graphed on my paper, I'm ready to perform some transformations. Remember that when you do composition, you're always going to work right to left because of that symbol that means the word following. So I'm going to begin by going ahead and reflecting all of these points over the y-axis. So point A prime will come over here to the point with coordinates 2, 2. C prime will come over to the point with coordinates 8, 5. And B prime will end up at 2, -4. And again, this is not my finished product, but rather just the first stage in arriving at that finished product. So I'm going to go ahead and I'm going to connect these with some dotted lines. And just for the purposes of clarity, even though it doesn't say to state the coordinates, I'm going to go ahead and state the coordinates. Now that I've performed the reflection across the y-axis, the last thing I need to do to finish this question up is to reflect each of those points in the figure across the x-axis. So I'm going to go ahead and do that right now. A double prime comes down here to 2, -2. B double prime ends up there at 2, 4. And lastly, C double prime ends up at 8, -5. And because this is my finished product, I'm going to go ahead and use the solid line segments in order to connect. And again, although it doesn't say to, I'm going to state the coordinates. Just in case you're checking at home, I want you to be able to check and make sure that you have indeed plotted your points correctly. Excellent. So there's what I have for you on composition of transformations. As always, I want you to take a minute, think about what you saw in the video, put in your own words that are meaningful and relevant to you, what are the key ideas and important takeaways from this video, and summarize those under number 1 on page 19. And then with respect to these apply what you've learned questions, in number 2 it says explain. So explain is going to be to state the transformation that'll map the original triangle ABC onto the transformed triangle A double prime, B double prime, C double prime. Notice that in the picture, they've provided you with this intermediate triangle, this in-between step, which I like to use a dotted or a dashed line segment to represent. So in other words, describe first of all what transformation was done to the purple triangle to obtain the red triangle, and then lastly the transformation that was done to the red triangle in order to obtain the finished product. On number 3, you should be aware that there's a typo. This says triangle RST prime, and it should say triangle R double prime, S double prime, TW prime. And again, this one too, you're going to want to make that change on your paper. And when you name those coordinates, really the only ones that we want are the double primes, the coordinates of the finished product. All right, till next time, folks. We'll see ya.